Hello guys, today we'll be discussing about small string optimization, which is mainly done in C++. So this particular small string optimization is implemented in C++ libraries like std, basic string and ATL string classes, as well as it is implemented in Boost libraries, string libraries as well. From the name itself, you will be able to make out that this is something related to the string. So before going into details, let's discuss what is the small string optimization and is there any inherent issue with small string optimization. So for understanding small string optimization, let's implement a basic string class. So basic string class, if you just think of it, it will consist of a character array which is pointing to that buffer which is allocated in the heap, and it will have a size, and it will also have something called as capacity. So this capacity will ensure that it is to optimize the memory allocation in the heap. So this is the basic string class. What is the problem with this particular string class? So one issue with this string class is, for every string object, whether it is an empty string or it is a two-character string like AB, always you need to allocate memory in the heap. Memory allocation will happen in the heap. Even if it's an empty string, it needs to be, we need to insert the null character. We need to insert the null character at the end for every string to be a valid string. So in the case of an empty string also, we need to have this null character in the beginning. So this is the issue with this string implementation. We need, every time, whatever string that we need to store, whatever characters we need to store, be it an empty string, be it a two-character string, be it a large character string, we need to always allocate memory in the heap. So the problem with this thing is, everything is heap allocated. So how can we get around this particular issue? So one thing is, we can use something called as optimized version of the string class. Optimized string class implementation. So let's see how it is done. So let's name this particular class as string optimized. And we have it. Let's start with size underscore t, capacity of this particular string buffer, and let's define a union. So in this particular union, we will have something called as structure. So in the structure, we will have a character pointer ptr and a size underscore t size, and this is a heap buffer. So this is the heap buffer. And also, apart from this particular structure definition, we will have something called as a character array. Character array of s underscore char or something like that, and the size will be, the size of this character buffer will be the size of the structure, the size of the heap buffer. So this is how we can define this particular union. So in this particular optimized version of string implementation, you can see that there are two variants, or there are two locations in which we can store the string. One is in the heap, other is in the stack. So this is decided based on how much string, how much the character array we can store it in the stack. So that is decided based on this, how much memory we are allocating to this character array. As you can see, we are allocating something around the size of heap buffer. So this is heap buffer for a 64-bit system. For a 64-bit system, the size of heap buffer will come out to be 16 bytes. So we can store a string whose length is 15 bytes at least into this character buffer, and we don't need to allocate any memory in the heap. So that's how we can choose the location of storage. So how we can choose based on the size of the string that we are going to allocate. So if we are allocating a string whose size of the string is less than the size of this heap buffer, the string will be stored in the s_char array. There is no need to allocate memory in the heap, it will be in the stack. And if the size, if it is otherwise, we will allocate in the heap buffer, and the pointer will hold a pointer to the heap location. So this is in short what is called as small string optimization, which is a very good feature to have. It will try to speed up your memory, it will try to avoid unnecessary heap memory allocation, all those things it provides. So what is the limitation associated with this small string optimization? So there is an inherent limitation associated with this small string optimization when it comes to Visual Studio 2019. So let's talk about the limitations. So let's talk about the limitations of small string optimization. In the context of Visual Studio 2019. So in Visual Studio 2019, or you can say that with the Visual Studio toolset version 142, there is an inherent issue while we try to use the assignment operator of a string. For example, if you try to use any std string or std basic string, then it supports this small string optimization as we discussed before. Optimization it supports. So what happens? So when we try to assign a string, let's define for understanding purpose, let us define a string s1 and assign it to some value called a house, or let's assign it to some size, and we have another std string s2. We have defined it like this, and what we do is we do s2 equal to s1. So what we assume is that s2 content will become size, and s1 will also hold size. So under the hood, what is happening? See, under the hood, what happens is, since the string length is of 4 characters, this particular string will be stored. This particular string will be stored in the heap it will be stored in the stack, the character array that we talked about previously. This s_char, it will be stored in the stack buffer, or the small string buffer that we call it. So inherently we have a buffer inside std string which is called as _bx. This is a string object, and we have _bx, and again this _bx is a union that we discussed previously. It will just like a union, and it will have it will have the pointer to the heap, and also the other version will be s_bx, which is a union, and it will have something called as buffer, actual buffer, buffer. This is the stack buffer, and this points to the heap. So what happens in 2019 or Visual Studio toolset 142 is, this particular the destination stack buffer never gets updated from the source string small buffer. Instead, the _ptr, which is pointing to a heap, gets updated with the source string. So when we read s2, what happens is we read from the small string buffer, which is _buf. So as I told before, this buf will contain some garbage value. So we read a garbage value and we get surprised why it is not working, because it is just a simple assignment operator at the end of the day. So what is the workaround to it? So there is a workaround. So workaround is nothing but you do a typecasting. std string s1 typecasted to std string explicitly and to s2. So while doing this, what happens is the small string buffer content gets copied to the destination string small string buffer properly. That means s2 small string buffer underscore buf gets updated properly. Therefore, this gets updated properly and we can read the actual content of the string. So this is what the issue is happening in Visual Studio 142, which is not there previously in 140, which is 2015 toolset. So just be aware of it, because in our application we used to upgrade from Visual Studio 2015 to 2019 and 2022 and so on. So you might have faced this particular issue previously, or you are going to face this issue sometime in the future. Therefore, just be aware of this particular issue so that you can rectify it easily. So if you like this particular video, please do subscribe to this particular channel and do share this video with your friends and colleagues. And do check out this blog in the description box below. Thank you.